Now we. All right, now we're taking a video. You can zoom in.
How much? I love being a camera person. Wow.
Yeah, you're just gonna have to angle it up a little bit more. So I'll have to start you with that. So really quickly, we're doing a 5-step mathematics problem. So again, 4th hour, you guys worked on the kind of explaining it. 5th hour wanted to work on the math, so that's what we're doing right now. Again, phase change, just like John said, 2 and 4, and now you're caught up with the video. So with this, these phase changes occur because you know the temperature is constant. Can you do Q equals MC delta T when there's no temperature change?
No.
No, right? So that's why with those 2 steps, Q for 2 and 4, that's where you have, I'm going to rewrite this to make it look a little nicer. That's why you have the heat of fusion and vaporization times the mass. Okay? Now again, this is for 2, this is for 4. I'm just breaking it down because it's the same equation. Also, these equations were not given to you on the quiz or the test or the homework. It is on the final, like I just said as a reminder. This equation is on the final. Okay, for the first time, I gave it to you. So, that's where we have these. Now the rest, again, Q1, 3, and 5 are just Q equals MC delta T. And that's it. So if we begin, Cassandra, what temperature do you want underneath 0? Underneath 0? Give me negative 10. Nothing crazy though.
10.
Negative 10 is cool. And then above 100, let's say, what do we want? Anique? 104. I like it. Okay. And the mass is. Brian, what's the mass? How many grams do you want? 50. Excellent. So to solve for these, okay, you're going to be given everything. I do give you all the C values. All the C values are given to you. You do not need to memorize any of those numbers.
Oh, those are the constants.
Yep, those are constants. Yep. The specific heats of those things. Q1. And we're going to say that we're heating it up. So we got mass is 50. Specific heat of ice is 2.1. Yep. Should be 1. And the delta T is going to be 0 minus negative 10. Again, delta T is T final minus T initial. And our final temperature, because we're heating it up, is 0 for step 1.
Final?
For 0, yes, because we're heating it up. It stopped at 0. A lot of times, what I saw you guys doing, you were going negative 10 to 104 every time. If that was true, the graph would look like this. That isn't what happened, right? The temperature took little mini vacations. 1 change, 2 change, 3 changes. Okay? So you've got to be careful with that. So again, the final is 0. I'm gonna say heating it. Okay, I'm just making sure you know it's heating. Q3, 50, 4.184. Final temperature is 100 because you're warming it to 100. 0 is where you start.
Where did you get the 4.1?
That is the specific heat of water that is given to you. Okay, and the same thing with this. These are given to you. You just need to make sure you're using the right one. Yes, go ahead.
Okay, so I know that I did this, but like I know that when you explained it, you said that I was going in like a straight line.
Yes.
How do you know when to use like the specific numbers, like the 2.1 or the 4.1?
That's an excellent question. So the reason that you're going to know when to use, like, which one of these 3 do you use, is that I'm going to tell you, hey, this is a specific heat of ice. This is a specific heat of water, and this is a specific heat of water vapor or steam. Your job then is to know, hey, what is water at negative 10 degrees? What is water at negative 10 degrees? Ice.
Oh.
Right? So your job is to know that. So you need to know, oh, yeah, this is ice. I need the ice number. Water at 20 degrees, 30 degrees, 80 degrees, it's water. It's your job to know that. And above 100, it's water vapor. Your job is to know that.
Oh,
Okay. So again, think of the temperature, and imagine if I had this water in front of me at this temperature, what would it look like? If it's -5 degrees, it should look like ice.
Wait,
Yes.
for Q5, why is the 100 at the end now?
Excellent. Because it's T final minus T initial. For 5, we started 100, and we're working our way up to 104. Because we stopped here on this one, but that's our new beginning for 5.
But then we start off at 100. Oh.
I think you just saw it. You just saw it?
Yeah.
Okay.
Initial.
And that's where you got to be careful, right? There's these 3 temperature zones, and I saw a lot of you were putting these 3 lines here. I saw that actually on a lot of you. Kind of remind you there's 3 different values.
That's why zero's at the end for Q3.
Yeah.
Because 3 starts at 0.
Yep.
in the graph, are you
'Cause-
gonna
and
give
then we
us
have to
the 3 values?
compensate for this flat line. Sorry.
Are you gonna give us the 3 values in the graph, or do you have to figure, like, put them, like, in?
The values are given to you. I will be honest and say I don't know about the graphic. I'm still working on the final just a little bit with fine tuning and things. The final's done. Just fine tuning. And if there's a graph or not, I couldn't tell you if I did not. Those are basic, straightforward, okay? What'll happen is with the 5 points, right? Because if you know this is a possible question, let's say, I put 100 minus 0 for like all of these, or I put, -10 to 104 for all these. That's one mistake, right? I'm not gonna dock you 1, 2, 3 points because you goofed, or I'm not gonna goof like a half for 1.5 total. If you make one mistake and you follow through with it, I'm gonna take 1 off and I'm gonna stop. Okay, so you guys have noticed I do that a lot this year, right? If you make one mistake on part A, you can still get B, C, D, and E right. I'm not going to punish you all the way through. You've had teachers that do that. I disagree with that. Okay, so again, this is that one little thing. You can still get a 4 out of 5. A lot of you did get a lot of points out of that question on the test, even though you goofed this. Okay, what really got a lot of you on this one was this one. Okay, that's why I'm giving you this one. With 2 and 4. Actually, have any questions on 1, 3, and 5? The 50 will be given to you, obviously. The C's are given to you, and the delta T's are given to you. Okay? If there isn't a graph, draw one. Okay? Because I might give you up, I might give you down. I can make it cool. Okay? I can make it cold. I can make it snow. I don't need to make it rain. Yes.
What about, like, because I know that at one point you said that we were gonna go from 5 to 1. Like,
Yeah, that's the example I was just talking about. I could cool you. I could say you put this water vapor into a freezer,
are you?
and then you're going backwards.
Are you gonna do an example?
I'm not going to do an example of that because the only difference is your delta T's would switch because you're cooling down. So your initial is now 104, your final is now 100. This would flip. That's the only change.
Would the graph still look the same?
The graph would be the same. You would just be going from 5 to 1, or you would go 1, 2, 3, 4, 5.
Okay.
Either way. But again, just keep in mind, final minus initial. If you know this, you're safe on up or down.
And if it's going backwards, instead of 104 minus 100, it'd be 100 minus 104?
Yep. And then that would happen here and here. This would be the same. This would be the same. So 2 and 4 would not change. And you would get negative numbers then, right? Because you're going to have some negatives then. That's okay. You could be exothermic, right? Negative Q is exothermic. It can release energy. If it's releasing energy, shouldn't it cool down? Because I'm losing all the heat energy, so I'm becoming
Is
colder.
it always going to be exo then?
Well, if it's going down, yes. But if it's going up, it's end up. Yeah, heating it is gaining heat. This is exothermic by definition.
If we draw the graph incorrectly on the test, will you take off points?
If you follow through with the math, no. No. I would, and if I did take off points, the most would be 1. I don't see, if you drew an incorrect graph, if you drew an incorrect giraffe, no, if you drew an incorrect diagram or graph and then you did all the math correctly off that, I might, -1 or -0 would probably be what I would do. No. Honestly, leaning probably toward the -0 because on a 5-point question, if you're doing each of these steps right, do you know what I mean? I'm probably, yeah. Probably, honestly, probably -0.
How would this look like as a problem worded, like without a graph?
What'll end up happening with that, it'll pretty much say, assume you have 50 grams of water. It might say this, you have 300 grams of ice at -5 degrees. How much energy would it take to go to water vapor 119?
As
That's
long
it.
as it, what is the energy change? Like, what is it?
Yeah, it's going to be a sentence. Like, it'll be one line of writing. Because all the questions we've had have literally only been a line. It's short. It's a short question.
So can we come after school?
Yeah, I can show you some examples. Honestly, you got one of these?
Yeah.
Okay. Second, where'd it go?
It's the last one on the page.
It is the oh, that didn't. I'm sorry about that.
Right, never mind.
It's this one.
Or-
It's a one right above the table.
Okay. What is the
It
total?
literally would look like this. The only thing I could flip is water, vapor, and ice. And then Q2, again, the delta H of fusion is 334. The mass is 50. And then for Q4, it's going to be 2256 times 50. These numbers are given to you. I just told you that.
Why is it only two numbers, not the? Oh, never mind.
Because there's no delta T,
Yeah.
right? So you need to know how much energy does it take for this to, boil or condense. Sorry, boil or condense is this one. And then melt and freeze for this. And then you just need how much, right? Because it's going to take more energy to melt 50 grams than it would 13.
Wait, so Q2 and Q4 is melt and freeze? Or you said melt and what?
Well, 2 is this phase change right here. So what phase change is right here? It's
You're
0.
melting.
Melting or freezing. Right? It's going to be those two phase changes. This one's going to be the condensing and the boiling phase changes.
Today the only day you're going to stay after school?
No, I'm staying after school tomorrow. Today, because I said I'm going to stay till 7. I truly do mean that, okay? I told my fiance to go away. So she's not around the next 2 days.
That's so
That's fine. She has stuff to work on, so do I. No, I'm here until I'm literally going to be here until it's very clear that people are done or not really focused or just tired. So we'll see how long that lasts. I do plan on staying until 7. Then tomorrow I plan on doing the same thing. Thursday I plan on doing the same thing, and Friday I plan on staying as long as I can. I am going to the concert downtown. I'm not going to lie, Swanson. It's kind of making me do it a little bit, but I hope to hopefully by tomorrow know about Saturday. I want to come in Saturday.
Whoa.
I want to come in Saturday. My goal is to give you guys over 10 hours of review.
You won't.
Oh, yeah, you're good.
You're fine.
I'm not going to calculate all that out for you. We'll challenge you to do it. Okay, add them all up and you're done. This is that little Hess's law thing. The sum of each little step add up to the whole. So this is a little bit of Hess's law, just a tad. And then that's unit 9. Cool. Given to you. Let me do this really quick for you guys. Purple. The numbers that I'm going to go in purple are given to you. Purple, 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 purple. Okay, so those are all given to you. You will know those words.
Mr. Taylor,
Yeah.
will you ever give us everything else, like the changes and stuff like that, but not give us the mass, and you'll be like, solve for X?
No, I had I had to do that once. No, it's a nightmare because you got to keep an X going. It's absolutely insane. No, you do not have to worry about me. I will ask you what the energy is total, and that is it. I won't ask you for, hey, what's the temperature, the last temperature I was at? No.
Isn't that when you add them all up?
Yep, you just add them up and you're done. No, it's gonna be like this, that's it. I'm not gonna ask you temperatures, masses, no. No, that's crazy. No.
Can you go over molarity and molarity?
I would love to go over those two things. Unit 8. M versus N. Karen, what am I at on the video?
14 minutes and 20 seconds.
Thank you, you're the
different
best.
than on camera, because you're so mean.
Dees.
She runs that.
I'm a little say
All right, let me take a test real quick. 1, 2, 3, 4, 5, 6, 7, 1 T. Who am I missing? I already got Phyllis outside.
You got carrot?
I got Karen, yeah.
Isabel?
I got one again. Dang it, who am I forgetting?
Kevin Cruz.
Kevin's in the back, I got him. Everyone's here, aren't they? And I'm just crazy. So he moved, Phyllis is outside.
She's gone.
Kyle? Who?
He said
Diana.
someone.
Oh.
I saw her.
She's here, but wait. Why did I just mark her tardy after all that? No, she's at a company. Oh, DC. Okay, DC. Okay, so these are the two. Excellent question that you asked. And I'm going to tell you right now, this is where it's going to come up. Now, you might have noticed this. I didn't specifically say this to you, but these have kind of always been like liquid problems, and these have always been like solid problems. Like, I've been giving you like zinc chloride, potassium nitrate. Here I've been giving you like water, salt water. Different kind of salt water, but it's still salt water.
You're right.
That's really what I've been doing.
Is it gonna start like that?
Yeah, so if you're looking at the problem, it's going to kind of help you out. Also, this will be italicized, okay? It'll be italicized. So, molarity is, and these equations are both on here, molarity is N divided by L, and this one is moles divided by kilogram. And that's where I'm kind of getting that from. So, either way, you need moles. You are allowed to use Mole Island. Holla at your boy. So you can easily figure that out. You guys are good at molar mass. Okay, you guys are experts at that.
I don't know about that.
Decent.
Moles.
And his moles.
No, it's mine.
I can write that. I can write that.
You're showing up in the
I don't
memory.
need your sarcasm.
I'm not doing that. Shh.
I wasn't talking to you. I was talking to Marie. My shush was for her, not
What
you.
did I do?
It's what you didn't do.
He's spraying you on camera. I'm not salty.
He's still in
Just a little
Well, yeah, you're not salty. You're a human. You're not sodium chloride. You are a living, breathing human. You are
Oh my
not
god,
salty.
that was so funny.
I don't even know if I'm in the shot.
No, it's just your hands.
What
Good.
was the last, the 5 steps? What we was
Oh, that was going to be Unit 9. The math specifically is Unit 9. So these are the two equations. Honestly, solving it, you guys have been really good. If you would like, with your permission, I'm guessing you didn't want like this. I'm guessing you wanted more application stuff.
Yeah.
Because like I know you know this, or maybe you flipped them, but you know the equations. What I'd like to do now is where is this useful, right?
Yeah, and like,
Here's where it's useful.
Yeah, it's useful when you're making medicine.
It is useful for medicine.
Yes, Marie.
This
Yes,
one is
Marty.
useful for
Fernando
medications.
asks. Therefore, I need to
Shut up.
Shh. Stop, baby.
Can I film her?
move it.
She didn't give her consent, so I can't.
Okay.
I give my.
That's where these are very useful. Okay. It's not going to really be them standing alone. I know you guys can do that. That's where honors stops. Honors just talks about this. In this.
That must be nice.
Honors doesn't know what this is.
Fernando, stop.
Is that a B after the F?
Right.
This is KB of well here.
Freezing
Let
and
me,
boiling.
Oh.
yeah, because there's different concepts. Here, let me pull it up really quick. I'll copy and paste it right in here for you guys. So I'm gonna make you guys a copy of this. You guys will be given. Oops, wrong unit. Sorry. I just met you. And this is crazy.
You're on video like this.
Here's my number. Shout out Karen. Why not?
Whom?
She's like,
Do your thingy in front of the camera.
It's A-okay.
wait, does that say F1B? I have some.
It says KFKB. Because there's.
It's either B or
KF
or B.
Yeah.
or B. Oh, yeah.
Yep.
Or
Not or B, or B.
And again, I apologize that notation is confusing, but that's how they're going to do it in like upper level classes. Like, there is this.
Mr. Taylor,
Yo.
What is a KF comma B?
Excellent. It's this.
Oh, that's a
Do you remember this chart a little
Oh,
bit?
yes.
So what it says is,
So that's a comma.
this is an important thing. This is a good question. Okay, this is a good question. So different chemicals freeze and boil at different temperatures, and it takes a different amount of energy for you to do that. So the KF and KBs are the So the KF and KBs are the constants of each thing. So for example, benzene, this is the freezing constant, how many degrees per kilogram mole. And then KB, that's how, I guess, essentially easily it boils. So if I'm doing a freezing problem for benzene, I want this. If I'm doing a boiling problem for benzene, I want this. So this chart, if this problem is on there, will be given to you. I don't expect you to memorize this. And it will tell you if it is on there, this will be the exact chart. You will see.
For delta T, what does I equal again?
I is the Van Hoff factor.
Huh?
So for example, like sodium chloride has an I factor of 2.
Oh, because it's just, oh, because it's 2.
Okay, then you tell me this to see if you're an expert.
It has 0.
3 is correct.
Oh, wait.
Is that you, Fernie?
Fernie.
Fernie.
Fernie left.
Does it, like, isn't it like sometimes it has 0 or 1 mistake?
Yes. Covalent things are 0.
Oh,
See, and you're laughing at me.
Wow.
well, I didn't laugh at you. I laughed
I'm
at
playing as a dog.
I'm the one who laughs. Because covalent things don't break up. That's ionic things break up. Ionic things dissolve in solution. Covalents don't really. Easy. Ionic things have metal in it.
From the chart from that side.
Yeah. Under the staircase, ionic above covalent.
I never said I was telling to, but okay.
But you are.
Oh, you're on camera.
So, the only really thing with these guys, and there are practice problems inside the math problems. I believe there's 2 of each of these, to be honest with you. I should have put 2 of each. I hope I did. That's, oh yeah, there's, yeah, there's 2 of each. Yeah, I got, 3 and 2, actually. Yeah. So there are plenty of practice problems with those for you. Those are the big application ones. The big thing to consider, just be careful with it. I have had people flip them a little bit. But again, it's going to be a cursive, like italicized M. It's all bad.
You're looking for Guadalupe? She got in trouble.
It's Vio.
She got to go to the office now.
Is it for bio?
Yeah.
It's bio. I can see it in your hand.
Yeah,
What are you talking about? Peters, welcome back.
Hello.
I'm here. Is anyone else here?
No.
Did anyone, wait,
Did you go
did anyone?
No, I've been
Like,
Alright,
is this B stuff in the
Well, I'll do, B. Prior.
I'll see if I can see pressure. So, you gotta see the bio people.
Oh yeah, my back is so sore.
Oh, it's, okay, it's over there. Okay, I'll have to get it out. I forgot, I put it around her nail I made.
What?
You put it, yeah, put a little nail so then it won't fall. Should I just keep this out over here over the summer? Just so
Yeah.
it's fine?
Mister, like, we
But
can
it's
never
gonna
see
fade.
its face.
I know, I never, well, yeah, I do all the
It's
time.
gonna what?
It's gonna fade because of the sunlight.
Yeah,
It does that?
but it's also not as much. Yeah, it has a face. Oh yeah, it'll fade.
Why?
I could show you, well, I could show you things that fade. I don't want to. Anyway, are there any questions with this really? It's really just the math problems which you have now. Yes.
Wow.
Can we do?
Decent.
I still don't get the Charlie or.
Look,
I don't-
Charlie.
Le Chalier. Le Chalier.
Like I keep it 20 minutes.
The Charlie.
Talking about it. Some people are gonna get sick.
Hola, soy paisano y.
Lip chat.
The chat.
Yes,
What was
Fernando.
that in Google Plus group chat name?
Ew.
Chat.
With an XD face.
Be white.
Or an XC.
First thing. Le Chatelier's principle is what?
Lord equilibrium.
How close are we to 30?
The stress one?
5 minutes.
5 minutes?
Yeah. Well, actually 4 minutes and 45 seconds, but.
Who's content?
Yeah, who's counting?
Karen.
We'll see you in the next episode.